My background is in medicine, and actually a specialist in occupational medicine and environmental health. And I started my education in this town of Odense at the clinic of Department of Occupational Medicine and Environmental Health in many years ago. Then I met a colleague which I have been working with since, namely Philippe Grandjean, the professor of environmental medicine here at the University of Southern Denmark. And we decided early on in the middle of the 80s to look at the effects of mercury, of metal mercury, which was the Faroese were exposed to by eating marine food. By saying that, I'm telling you that we have a global contaminant problem with mercury because people eating certain species of fish or sea mammals will be highly exposed. And the reason I went into this field, which is a bit outside the main field of occupational medicine, was actually that at that time there were some doubts about it. It still is. Where is the lower limit for where mercury exposure is safe? And so WHO was asking people to do some prospective studies on bird cohort, because it was clear that the unborn, the fetuses, they were the most vulnerable. So prospective studies would be the most reliable methods to conclude in this a bit complicated question, which came out of Minamata many years ago with the Minamata accident, and the same in Iraq in the 60s. So Philip and I started to do these studies in the Faroes, and we are still doing it. But a little bit about the background here, where you are. About 20% of the world's gold is produced by artisanal or small-scale gold mining sector. This sector is also responsible for the largest release of mercury to the environment of any sector globally. Well, this is an important statement. It's about annually about 400 metric tons. It is spread over many countries, and the burning of mercury gold amalgam in the gold shops is really both a local and a global problem. I used to answer, in old days at least, when journalists were asking, where does the mercury come from? Then I always was blaming the coal burning power plants in Europe, in US, in China nowadays especially. But if you look at this this picture from UNEP, their mercury assessment 2013, you can see this is not the case. The main contributor is actually there. That is the majority of the cake from artisanal and mining activities. And this is, I think, this is very important to bear in mind, that these activities in mining and especially in gold mining are really major contributors. Then I will present you for another picture which I think is very informative. It's a very common question. Mercury has been there always, because of course mercury is a part of the earth crust, and it's not invented by man, but it's released by man. If you look here, it's a very simple graph. Here in our days, you have 100%, and if you go backwards in different species, you can see that it starts rising in the middle of the 19th century, around the Industrial Revolution, starting in around year 1800. So this is absolutely a good demonstration that of the human, so to speak, origin of this problem. Because I see it's a problem because, as I will show to you later, we have it as a problem in the Faroes and in the circumpolar area. All these countries eating sea mammals. In 2001, the UNEP Governing Council decided to undertake a global assessment of mercury and mercury compounds. In 2009, the Governing Council decided to develop a global legally binding instrument. And in 2013, 124 member states approved the Minamata Convention on Mercury. And that was, by the way, ratified by US the same year. That's a bit. Now, in August this year, some days ago, more than 15 member states had ratified. And that was a criteria to have it to get it in force. So now it is up and running, the Minamata Convention, with the clear aim to reduce the mercury exposure to living organisms, including man. I will not go in detail with the symptoms, but as you know, we have different kinds of mercury. We have the elemental mercury, we have the inorganic mercury, and we have the metal mercury. A lot of mercury ends up as metal mercury because what is released are, for example, led to the rivers or by the atmosphere will end up in the big oceans, and at the sea bottom it will undergo a biological transformation from to become organic by microorganisms, and then starting climbing up in the food chain. The small organisms are eaten by the bigger one, and in the end, up in our part of the world at least, and in other places like in the Amazon, in the Pacific, for example on the Seychelles, you can see that people are highly exposed because they are eating highly contaminated fish and sea mammals. There are some differences in the symptoms in the different kinds of mercury, but elemental mercury, that is absorbed by inhaling. That's not the case for the other ones. And here the inorganic, which can have another symptom profile, but in the end the impact on the central nervous system is the important thing. That is in common for all three forms. And these are the classical symptoms of metal mercury poisoning, with the loss of peripheral vision and pins and needle feelings, usually in hands and feet and around the mouth. But what I've been working with especially is effects on infants and children. And there you have a variety of subtle effects on the central nervous system. I will take this, this is a lot of text, but I will read the first part of it because this is important. This is the conclusion of the UNEP Mercury Assessment 2013 report on Arctic, the circumpolar area, that is the North Canada, Alaska, Iceland, Faroes, northern Norway, and Sweden, Finland, and Siberia. Concentrations of mercury in Arctic marine animals today are about 10 to 12 times higher than in pre-industrial times. This means that on average about 90% of the mercury in marine predators such as seabirds, seals and whales is anthropogenic in its origin. And that is really an important statement, that almost all the exposure in these animals are coming from anthropogenic activities. I'm in a group preparing a global mercury assessment, and we are been looking during the literature recently, and we can see that papers about the exposure to mercury is mainly from US and Europe and a part of South America. But as you can see, there are big parts of this world map which are quite wide in nature. That means the literature is not so on mercury exposure is not so common there. The picture to the right here, this has been my walking field, so to speak, because I've been active in Arctic monitoring assessment program for many years. We have tried to assess the mercury exposure in these populations because they have that in common, that they are eating sea mammals. For example, in Greenland, seals are very common in their daily food, especially in the north and on the east coast. And so the exposure has been high. You saw Raoul's picture on mercury levels in children. I think the highest was around 10, but then we started up in the Faroes with a median of 33 microgram per liter. So the exposure in some communities around the North Pole have really been high. So so we have made a report, and in chapter 4 in that report, I was the lead author of that, health effects associated with measured levels of contaminant in the Arctic. I will give you some conclusions from there. They have in Nunavik, in Canada, they have done longitudinal studies, and they on children, and they concluded at the age of 11 years that mercury had a negative impact on brain. They found that as well was the case with lead and to some extent of PCB, but I will not cover PCB today. I will stick to mercury. So now come this picture. It was explaining it to you. See, we are there. The Arctic Circle is actually up there somewhere, so we are south of the Arctic Circle. But in this context, we have been acting as we were inside that circle. The problems in the Faroes, which gave this research possibility, so to speak, opportunity, was this habit of eating whales. This is an old tradition and been so for hundreds of years, and this has been really a very regulated way of catching whales, because some public officer will be there, and everything is divided in the society. So this is basically not commercial. It is it's a social arrangement from old days, and it still is. But the problem has been, to me at least, in this research, that so many international organizations have tried to come after us, saying it is not good to hunt whales because they are some really high ranking animals and should not be killed. And then what happens in the Faroes, I guess that is, as in every culture or tribe pressed from outside, everybody stick together in order to defend our right to kill whales. So nowadays, this summer they will kill more whales than ever, I think. Just as an international, given the international pressure, a proper answer. So I'm squeezed between the old culture and the health message, which I will bring to you in a moment, and the reasons why. We, Philip Grandchamp and I, we went on this work because we found that the Faroe Society was, from an epidemiological point of view, was quite an ideal society, because the exposure span was high, from the low exposed to the high exposed, and the society is extremely homogeneous, a Nordic fishing community, and with high transparency, a bit conservative. Women at that time were not drinking much alcohol, and in the initial research work, we saw that the participation rate was high, about 90%. So, no, I will go over that. In whales, in toothed whales, we have the mercury in the meat, in the muscles, but the blubber, the fat tissue, is really high in a lot of persistent organic pollutants as well. I mention this here because when we went out looking at mercury, we had to include in our analysis the pop exposure as well. And that has been a major task. You can't say anything about mercury effect without looking at the other effects. Mercury has been, if anything, increasing. It's around 2 ppm, 2 microgram per gram in whale muscles. But the good thing from a public health point of the Faroes was that I had an alternative as a public health officer. I was the chairman for the Board of Public Health, that I could really communicate that our dominant fish species, namely the cod, is really low in mercury, a factor of 100 or so. So that was an alternative. How we measure it? We used different methods, neuropsychological methods, physiological, neuropediatrics, and neuroradiological now in recent years. And that was because we choose different approaches because after funding or establishing the cohort, we had to wait for 7 years where we really could examine the children in details, and then we could not afford to do it wrong, so we just mixed a lot of several methods, and that was good because they have been confirming each other. For example, in the psychological in neuropsychological method, we had a lot of different tests. I will not go in details, as you can see them here, and what we saw was actually quite clear that, for example, in reaction time, the highly exposed here had a slower reaction time than lower exposed. And here, if you take different psychological domains, there's the high exposed is the white columns, and you can see they are higher than the black, and indicating that a bigger part of these children had difficulties in their test scorings. In the neurophysiology, I think the most time-consuming was the visual evoked potentials, which is you put some electrodes on the skull and stimulate the child through ear and eye, like here, and then you can measure some signals according to this diagram, and relate that to mercury exposure, as we have done here. This is maternal here, concentration at birth, and you can see this is a sound stimulation to the ear, and then we measure how long time the signal comes to its end position, and we have published that. Now it's not submitted. It's published years ago. There is an association there. The higher mercury, the slower the signal will travel. And here the child, mercury at 14 years of age, the same picture. I will not. Then we went to the pediatric or neurological methods, namely using a kind of a neurological optimality score, which was invented in Holland, and we had the inventor coming to us and instructing us, trying to find out, and you can see here the same pattern. The higher the mercury exposure, the lower the optimality score. So that means that now this is in the third area. We have the psychological, the physiological, and now the clinical, indicating in the same direction. And last, we took some of the children to a functional MRI. That means that we gave them some psychological tests when in the MRI scanner, and you can see that to the right, low developmental exposure to mercury or controls, and high are on the left side, and you can see the loading picture. The two sides are different, and we have concluded in our article that it's more energy consuming to do this, in this case, a simple finger tapping when highly exposed to mercury, indicating the negative impact of mercury. Then I will mention another common question, namely the good qualities of seafood. Can that compensate? Yeah, we can see in our analysis that fish main meals, as we asked in our questionnaire, they had a modifying effect, meaning that when the mercury effect became more clear when it was controlled for fish intake. And selenium, on the average, that is a common question too, and especially nowadays, selenium is supposed to have a very protective effect. But in our study, on the average, selenium was present in cord blood in a molar excess of about 10-fold above mercury. We did not see that selenium had a significant protective factor against mercury toxicity. I shall mention now that I was participating in the international conference of mercury in Rhode Island a month ago, and our colleagues from Rochester, they had several presentations indicating that very high levels of selenium, for example, which is the case in the Seychelles Islands, that could be protective, because they indicated that the mechanism could be that the good effects of selenium was neutralized by the mercury. So if the selenium concentration was very high, then compared to mercury, the mercury effect on selenium would be eliminated. Yeah. So in our conclusions in our context and in the Faroes, we see not the selenium as a selenium insufficiency as a problem in our part of the world. There is a effect on blood pressure as well at 7 years of age, a negative impact you can say, because under 10 microgram per liter there was an association with both diastolic and systolic pressure. And we saw something on heart rate variability. Most likely we are impact on the brainstem. So our conclusion has been that neurobehavioral effects most clearly on attention, memory and language, but also on visuospatial and motor functions. We have followed these children now. They are 29 years of age, and we did a thorough central nervous system examination of them according to the line I show you. Last time at the age of 22 years, and the effects were still there. On that basis, we have concluded that they are permanent. We hoped in a way that they disappeared during the maturation. This is just showing you the cultural aspects in my country, and I can promise you that in other parts of the circumpolar area, this is, for example, the seal hunting, seal consumption in Greenland is really an important part of their cultural identity, and it has been in the Faroes as well. So I had really a hard task all this year, since in my case, since the mid-80s, starting communicating the negative impact of mercury, and perhaps it is a bit difficult to understand that, but the point with this is the communication activities, and this is a reduction of mercury exposure. And so that picture should indicate a successful story of intervention. So I and my the first medical officer in the Faroes, we went out 10 years ago and recommended that Pál Weihe is no longer used for human consumption. And that was not well received by many people. So, because of that identity problem, but on the other hand, we have tried to communicate that very difficult and a bit abstract principle of the precautionary principle, that it is important to make your to be on the safe side early in life. And for example, if you take the exposure to the POPs, the PCB 153 has a half-life of 10 years, and I mean, you can't just consume blubber and then hope and then come to a conclusion that this was associated with some really serious harms. For example, a negative impact on the immune system, but you can't do anything with it. So therefore, we have tried to communicate this principle of we have to take action now, and but it has been successful, as you can see on this graph, which I am very proud, and it's even lower now. Bearing in mind that the exposure of mercury in the marine organisms are the same. It's the same as it was, but this is an effect of changed dietary habits, especially in women, which have been more. They have listened more than middle-aged men, I can say. So I will say thank you with this picture. This is my country, the whole country actually, taken from 10 kilometers altitude. Thank you.